Hello, hello. All right, the mic is working. So, good afternoon or good evening, everyone. Thanks for coming. Today I'm going to show you a bit about a framework called SST, which used to be serverless tech, but then they just decided to stick with SST without any meaning, because now you can deploy there also containers. It's a framework created by a group of 3 guys, basically, but they managed to get it into big enterprise companies because apparently it's really worth it. So yeah, let's take a look at it and see if you could use it in your setup. Yeah, a little bit about me. I'm from Brno. Currently, I work at Deepnote, where we are building data notebooks and trying to help data teams to solve their hardest problems. I'm also AWS Serverless Hero, which is this group of experts on AWS that AWS picks, and then we have access to information and people from AWS. And I'm also one of the co-organizers of our serverless meetups in Brno. Yeah, this is about our Deepnote. If you are interested in data science, TypeScript, Kubernetes, and stuff, we are hiring, same as LabLabs, right? And now let's get started. So as I mentioned, it's a framework for deploying modern web applications. It's primarily in TypeScript. Who is using TypeScript at work? Not much. So Terraform? Oh, I see. And main supported providers are AWS and CloudFlare. CloudFlare is an interesting one because how many of you used Wrangler? Yeah, not much. You didn't miss anything. It's a very horrible tool that they provide. So finally, there's a good way to deploy apps on CloudFlare through SST. And since it's based on Pulumi, you have freedom of using any Pulumi provider you want. And Pulumi is then under the hood using Terraform providers, so it's quite safe in this sense. Who is using Pulumi? Another show of hands. I see. So Pulumi is a way how to write your infrastructure as an actual code. So you can write it in TypeScript, Python, Go, similar like CDK basically. They were born in similar times, but they were like the first one. And compared to CDK, I would say it can be easier and better to debug because with CDK, you get the issue that it gets compiled to CloudFormation, but then when you get the error, those errors are in CloudFormation, but not your CDK code. So it's very hard to track and debug. So in this case, Pulumi is much friendlier. Here is a little comparison of the frameworks currently available, I would say, or like the big ones. You can use Serverless framework, which is great for deploying applications, but deploying DynamoDB tables, RDS, VPC, and like the classic infra stuff, which you need anyway, it's not good because you need to basically write a raw CloudFormation. There is no multi-region support, there is no cross-cloud support, and the sustainability or reliability of the company behind it might be a bit questionable because they're struggling to get the revenue for a long time. Then we have CDK, where CDK is backed by AWS, which is great, stable. It's great for deploying infrastructure. It's OK for deploying applications, but there is no multi-region support and cross-cloud support. Like, you can forget about it. By cross-cloud support, I mean something like CloudFlare or Twilio, that there is a provider who is doing service the best in the market. So with CloudFlare, you get the CDN with all the protection. With Twilio, you get the SMS, voice stuff, which are not that good on AWS. So that's what I mean by multi-cloud, so that you can build your perfect stack, basically. Then we have Terraform and Pulumi, which basically have the same stats. And now Terraform, since it has been acquired by IBM, basically, we can say it's safe for some further development, or let's say at least maintenance. And Pulumi still standalone company, so there can be a little bit of risk to be aware of. And with SST, What I'm going to show you today is that I think it's great for deploying infrastructure, great for deploying applications. You get the multi-region support, you get the cross-cloud support. But of course, as I said, it's a small group of guys developing it. So it's a good thing to be aware of. But I mean, for example, one of the big Czech banks is using it, for example, and I was pretty surprised by that. So apparently, it doesn't need to matter. There's an interesting article called Moving Away from CDK by the SST team, which describes all the issue with CDK. And there are many. For example, you can deploy a CloudFormation template, CloudFront distribution. And this CloudFront distribution, then you need a web application firewall for that. So you can deploy the distribution in whatever region, it's global service, but if you want to deploy the firewall, you need to go to US East 1 suddenly. So if you do it, for example, in serverless framework, well, it gets troublesome because, again, you need like multi-region. There's a ton of custom resources being used. It's a feature of CloudFormation. And yeah, so I recommend reading it if you are in the CloudFormation CDK world. It's quite interesting. Got the picture? Good, thanks. In the company I worked previously, we had our serverless tech stack basically from 2018, and it was built primarily on serverless framework initially. And it worked fine. There was nothing better, I would say, back then. Then CDK was born. In the early days, it was like risky, controversial move, we could say. But in the end, it showed as the winner, you could say, and we were experimenting with it. But I didn't like it that much because I imagined there could be done something better since you have the power of TypeScript and Node.js, and that's where SST version 2 came in. And I immediately realized that this is exactly what we want. And since then, since 2022, we were building on SST. And currently, there is a new version of SST v3, which we are going to take a look at today, and I will see if my colleagues from my previous job will adapt it and continue with it. So yeah, let's see some example. Let's create a Lambda function. So who has used Lambda functions before? Quite a few hands, that's great. So we are going to create a simple Lambda, which is going to give us Lambda URL. User is going to call the URL, very basic. So how do we get this deployed? So first thing first, we will create a Hono application. It's like Express.js for creating REST APIs. And then we will just call SST init in the folder, and it's going to create, yeah, here's the animation of the CLI. So it's very straightforward, quick, just create the SST config file, and you got it ready for your application. Here we have our index.ts and SST config, as I mentioned. In SST config, we have the main two functions are app and run. App function gives us a way how to define the application. Like, let's say it has some name, it's deployed in some region, it has some removal protection, let's say. I mean, if you are on production, you don't want to accidentally remove your application. And you also said that your default provider is AWS. So that's like the metadata about your application. And then we have our run function. So if we say we want to define our Lambda function, we just say new SST AWS function. We give it name, Hono in this case. And then we say we want to enable the Lambda URL. And here is the location of the handler. Very straightforward. Yeah, the next part is our actual application. So very simple, very basic. We just receive the GET request on the root, and we will return a text called hello Hono. So very simple application, but you can extend it to whatever endpoints you need. The next thing you need to do is you need to call SST.dev, which is a development mode for your application, same as, for example, from React or the front-end application like JS, that you can run some local development. And in this case, this nice terminal window pops up, and you can see the progress of your feature environment getting deployed. So you can see that the Lambda was created, the log group was created for that, etc. And then you will see the Lambda URL right below. So we can try to go ahead and call curl, and we'll get a response, hello Hono. So this way we were able to deploy a Lambda function with just a couple of lines of code and get a nice API. Here we can see the logs of the Lambda function, so we can see that here are the logs that are coming into our application, so we can see that the build has been done, then there's been some invoke, how long does it took, and this way you can see in your terminal all the traffic that's going on there. And there's this very interesting feature that they created in SST, and it's called Live Lambda feature, because with serverless apps, there's always the issue with you either test it locally or you test it deployed, but it takes time to deploy, and you are never sure which way to go. And here, they created a system where once you deploy your application in the development mode, it will deploy, instead of your Lambda code, their own specific code, which is helping to handle the logic that I'm going to show you. So here is number one connection coming to the Lambda function, and so the request from your computer is coming, you open it in your browser or you call it with curl. It comes over here, then the Lambda code, which they inject in there, sends an event to AppSync events, which is like the WebSocket API, and through that the events get to your computer. Here, the code is built, is executed, and then it returns back to the Lambda function and returns to your computer. So any changes you do are immediately propagated to your application because they're happening on your local machine. And I can say from my experience that the latency that this loop is causing is really good, I would say, bearable, absolutely fine. So in the end, it creates very good developer experience. So we got our very simple endpoint, but usually that's not what we have. We always need some database, let's say. So we can create an Aurora database. For Aurora database, we need a VPC. So we will just call SST VPC, and with these couple of single line VPC, we get created all the subnets and security groups we need. And then what we create is here my database. And we will say, all right, so let's create a Postgres. It's going to scale from 0 to 1 in this example. And we will store it in the VPC as mentioned down there. And then what we need to do with our function is that we need to add there the link parameter, which will grant access to the database. So it will also inject the credentials, which we will see in a minute, to the function. And we also need to put our function in the VPC to make sure that it is able to connect actually to the database. But what's missing here? It's not going to work when you develop it in the development mode. So what could be missing? Any ideas? Come again? IAM role. No, you don't need IAM role in this case. Yeah. It's gonna time out, actually, because the computer gets injected the credentials it needs, but then it's not able to establish the connection to the database because it is in private subnet, as it's supposed to be, right? And you need to create a bastion host or something like that. And we can be grateful that SST created a very simple parameter where we can say bastion, set it to true, and it will create a bastion inside our VPC. And this way, then we just need to call SST.dev install, and it will prepare, I believe, a network interface in the machine. And then, thanks to that, it will be able to route the traffic through there, and the application development will work locally. So this is the diagram. This is what has been added, the EC2 instance over there. And then this way we can connect through the tunnel to the VPC. The next interesting part is the credentials, how to connect to the database. So thanks to the link parameter, we are now able to read these fields, basically. We import the resource field from SST, or object, and we can see that there is this my database. And it's not coincidence. It matches the name of the resource, which we saw on the previous slides. And then you get the username, password, database, host, port, and you can put it all together here. And then you can just call the SQL and get a result. So this way, even if you deploy on a feature, SST is going to make sure that it's going to inject always the correct credentials in the runtime. It's during the build time, it encrypts the credentials, and then during runtime, it will decrypt them with the key, so they are trying to make it secure. Oh yeah, this is zoomed in. But this can get expensive. The code we currently saw means that for every feature, you will deploy a VPC, database, Bastion host, and for all this, you pay by hour, right? So with SST, we can do cross-sharing of the resources, or not just SST, like in general. This is a common practice, I believe, that you create a database and VPC only for your production and staging, and then you can share it with staging. So I'm deploying my feature deployment, and here I can just call vpc.get and get my VPC, which I deployed previously when I was deploying staging. And now when my application is being deployed, it's going to get deployed to the staging environment. And with the database, it's the same like with many other resources. So again, you can create your Aurora for your production and staging, and here on features, you'll just call aurora.get, put there the name of the cluster, and here you go. On your feature deployments, you can connect to the staging database. As I mentioned, first things first, you need to deploy your staging first, and then you can call your development command. So you call that deployment of staging once, and then your developers can call SST.dev locally as they develop the features. The next part is front-end hosting, because we have our API, we have our database where we can store our users, and now we need to give them some access through front-end. And SST has an interesting solution for that, where they, according to the documentation, they support many frameworks from Next.js, Nuxt, Solid, Astro, Angular, many of them. And with Next.js, it's quite special because who's using Next.js? Quite popular, I see. Vercel has built so many features where they basically make it so hard for anyone else to run it as good as them. And guys from SST decided that they want to try to provide the same experience. So they created an initiative called OpenNext, which was also picked up by CloudFlare. So now they are developing this tooling around Next.js to make it run in AWS and CloudFlare very well, in a serverless manner, we can say, so with CloudFront and other parts. Or you can always do classic static site hosting, right? It can work quite well in many cases. So we can create our Next.js application through this command. That's classic. And down here, with just 3 lines of code, we can start hosting it. So we will say, this is my web. Here is path to front end. Here is front end. And then SST will know what to do. We're still building it and deploying it and running it locally for you when you run SST.dev. So very, very good developer experience. So here you can see that I run SST.dev, and I'm getting here the next dev being automatically executed, and I can see that in the menu on the left side, I get the SST functions, my web, that's how the construct was called, and I get also information about the tunnel I mentioned before. Now, what we want to do is we want to pass the API URL to frontend. And, what we do is that we will put the API URL reference through next public API URL. Next public is a prefix, which means that any n of variables with this prefix will get propagated to your front-end build. And API URL is just our name, how you can call it. So then, when I'm on front-end, I create my component in React, and here I can just call process.env API URL. And then, when I run the application, so this is server-side rendering part of it, I can see that I got it in my logs over here. So this way I can link it through. So because in many cases, many companies are having these env files, these huge env files, which they are like dealing to each other, the team members, with the API URLs and the secrets and stuff. But in case of SST, when you link it through the code, it automatically gets ready for any feature development and linked together, the front end, back end, you name it. And yeah, then on front end, you just need to call fetch. You give it the API URL, and we will show it as the stringify data very quickly. So I can click the call the API button, and I get this result from my Lambda function. And I can see all the logs in the terminal. I can deploy it. It's going to be in the Lambda. It's going to work out great for me. Yeah, here are the logs. So you can see how each query, how long it took for each query. You can see all the requests coming in, even in parallel. So it's very nice and friendly. So key takeaways from me for this presentation, it is that what is SST? So SST is a framework for building modern apps on AWS and CloudFlare. Interesting concept is that monorepos, which contain both infrastructure and application code, can be a good fit in era of AI, because the agent can see your whole code base and is then able to help you much better, because it's not just about the application code. Oftentimes, it can be also part of infrastructure. And of course, it's good to ask a question if SST is a good fit for your team topology, because in many companies, there are still silos where there's like the infra team and the application team. And in this case, it's questionable how much sense it would make, but it's in general with serverless. Then if you are also tired of CloudFormation or CDK, it can be interesting for you to try Pulumi or SST. If you want something more infra-based, not an application, go for Pulumi. If you want an application to get deployed, go for SST. Or if you want to keep things simple, maybe you can just do very well with Vercel or Laravel Cloud. Not too complicated with AWS. There's also an option. And yeah, that's it for me. Thank you. Any questions?
Does it also deprovision the resources to be created?
Come again?
Does it also deprovision the resources you created?
Yeah, the question was if it deprovisions or removes, right, the resources. Yeah, you just call SST remove or destroy, not sure what's the naming there, and it will just like remove completely everything. So
when I start the application, it will deprovisions new resources, but does it do any other change, or how does it work?
When you run the dev mode, you mean, or the deploy? Generally, yeah, it provisions all the resources for you. Like if you say like create a new function, create a new database, it will start provisioning all the resources for you, and then you can just say like SST remove, and it will just tear everything down. And you can set there like the stage parameter, which will say if it's like production or staging, and based on that, it will like differentiate the deployments basically.
So does it make some diffs like Terraform, for example, that it knows when something needs to be also not only
Yes,
but also like
if it makes diffs. That's a good question. SST is built on top of Pulumi, which is basically built on top of Terraform providers. So it has these capabilities that currently I'm not sure. The version 2 had diff, the SST. Version 3, I am not sure. I would have to check. But the principles are the same, like Terraform, for example. So it has some state. You can see the diff. And then, yeah, it does the operations necessary to achieve the desired state. Go ahead.
Could you switch to the slide where you show how to connect to the Postgres?
Yeah. The beauty why I love this solution why so much is that, yes, it's being type checked. So if there is incorrect pairing of your infrastructure and your application, you will immediately know during build time, and it will not fail during runtime if you have proper checks in your CI. So this way, if the database is like renamed or you do a typo or whatever, you will get an error and you will know about it in advance. Sure.
Do you know how does it actually work? Like, I assume that you need to generate some types.
How this works? Yeah. That's very interesting. I mean, I've been really deep into SST. So how this works is that they create a folder where they will create the type files. Like, for example, back then, when TypeScript was new, if there was a library without the types, you had to create it yourself, right? So this way, they will do the declaration where they will like inject the structure based on what's generated from the application. So in order to generate the file, you need to write like SST generate types, or you need to like do SST.dev, which will automatically in background like recreate the file according to your needs. Or you can commit it, but I'm not sure if it's recommended or not, the committing. Yeah. Go ahead, yeah, sure.
Example of where this is actually useful for the local development compared to because AWS is official documentation on how to run Lambda functions locally. They have the local runtime in Docker containers. You can run Postgres in Docker container as well, so you can do this locally, like fully locally. Do you have some other examples where you cannot run it locally, like completely?
Yeah.
And you would actually need to run it with Dev tunnels and everything?
Yeah, so the question is about reason why the live Lambda actually makes sense instead of just running it all locally. For example, step functions. Have you heard about step functions? So you would have to have some, you would have to have some emulator for the step functions. And if there is some, you are posing yourself at the risk that it will be not correctly implemented, right? So for example, step functions, that's one. What else do we have there? Like, yeah, I mean, you can emulate GraphQL, for example, AppSync, like locally, right? But yeah, like SNS, let's say. You know, I mean, yeah, there is a way that you can do it with local stack, but you have to like set it up, everything. You need to point the endpoints, right, to the local stack endpoints and stuff like that. And I believe it's like maybe it could be, there are so many arguments that we could say that it can be like a religion. So I'm in a church of like the live Lambda, but of course it doesn't mean that doing it locally is incorrect. Both of them have different challenges, but
step function is a great example.
yeah, step functions this can be a good one.
Can you explain what is it?
What is what? Step functions? Yeah, sure. So Lambda functions have a limit of 15 minutes, how long they can be executed, right? And let's say you need to do longer tasks. So step functions is a way to chain your functions with logic. So like imagine a diagram that you would draw of your architecture or your like UML diagram. So you can have different steps and you can chain them together and put the like ifs, like if the response from the function is this, then go this path. So for example, there was like primary selling point for us to go serverless back then to use step functions because we had all these, we used to be in fintech, I worked in fintech, and we had to do a lot of KYC AML, like the checking if the person is terrorist and if he has done some frauds, and there are different databases and they are reliable, not reliable. So we wanted to have a system where it's like one transaction. So when user registers, it's going to be a huge, it's called state machine, where there are going to be all these steps like checking this and that and writing this to this database, etc. And you will know which step failed. And then we created a mechanism to rerun the steps so it can continue, so it keeps the context. So for these business applications, it can be a great fit, let's say, if that makes sense. Any other questions? All right, so I guess we can wrap it here and continue with the next speaker. Thank you.